Hello friends, welcome to our channel. Let's have a look at yesterday's daily challenge problem. Recover a tree from preorder traversal. So here we have a serialization of preorder traversal of a binary tree, but the serialization is very special. So here in the second graph it explains how this string is obtained. So basically at each node in this traversal, the output d dashes, where d is the depth of this node. So then followed by the value of this node. If a node has only one child, that child is guaranteed to be a left child. So we want to get the original binary tree from the traversal string. So here you can look at some examples. If you look at example 1, so you see here 1 is the root. At level 1, so you have 1 dash, so you have or hyphen. So 2 and 5, right? That's the two roots for the left subtree and the right subtree. And at level 2, you have 3 and 4, corresponds to the left and the right child of 2. Similarly for 6 and 7. So here, the number of nodes in the original tree is in this bounded above by 1000. So the node value is in this range. So that's basically the problem statement. So here actually what we want to explain in this video is regular expression. Regular expression in Python, let's see. And also because when we talk about tree data structure, we often use recursion. So here I'm also going to use recursion to build the tree. So here for this problem, as long as we know the value at the corresponding levels, then it's rather straightforward to build the tree. So observation. So it's very easy to build the tree. If we know each value, each node, its value and depth, right? Then we just use recursion. So here the thing is how to get this information. So here the answer is regular expression. So we can use regular expression here. Let me first do some prints so that you can get an idea, and then I'm going to explain the regular expression pattern. So here first I'm going to get this regular expression. This is the module in Python. So we find all, right? So basically what I'm going to do is this. So I have a big group, and in this big group I have two other groups. So this is a hyphen, and then this hyphen can appear 0 or more times. That's the star, right? Meaning special character. So then also I need to have the digital number. That's the backslash and d. And then it should be at least one time. So we use an add, right? So then this is the traversal string. So notice that in this pattern, so each parenthesis represents a group. So now let's see this is the result, right? So let's do some print so that you know what's happening. So here are the 3 groups, right? So let's run it. So if you look at example 1, so we get 1. So that's the whole information. So there's no hyphen, and this value is 1. So similarly, you can look at 2. So 2 front is the 1 hyphen, and then followed by 2. So the hyphen part will be just 1, and the numerical part is 2. For 3, you have 2 hyphen and 3. The first part is 2 hyphen, and then this is the 3. So similarly, you have 5. So 5 is level 1, right? So the depth actually is the number of hyphens in the second component. Actually, the second component corresponds to this group, to this bracket, parentheses, hyphen star. And this third component in the tuple actually corresponds to the numerics or digits. So once we have this path of information, and then we get these values are very simple. So we can get this node. So basically, the information I want to get is the length of the node at component 1. So then this is the one part, right? And then another part is integer value of node at the second index 2 here. So basically, this is the for node in the result, right? So you can print out this nodes so that you can see. Meanwhile, let's print out this result. So together, you are going to get a good idea. So so this corresponding to the level is 0 and the value is 1. So here, level is 1 and the value is 2. Similarly here, 3 is level is 2 and the value is 3, right? So that's actually sufficient for us to build the tree. So now let's build the tree. So in order to use some pop options from tail, for example, so for this, basically the first one, this one actually corresponds to the 0 and the root value. So what I want to do, actually, I can do a nodes equals nodes, just reverse it, right? So this is just for convenience. So now let's write a hyperfunction. So define a hyperfunction. I'll call it make tree or build tree. So basically, the parameter to be passed is the depth, right? So first, I want to write a bound condition or stop condition. First, if not nodes, right? So notice the scope of nodes. If not nodes, this is the one condition. Or depth does not equal to nodes -1, 0. So originally, you can think of nodes -1, 0 is this guy after we do reverse. So we start from level 0, right? If it's not the case, so we're going to return none, right? So now let's do preorder traversal. So we basically first do root and then left and right. Left means left subtree, right means right subtree. So first let's get the node value. So let's see the root value. The root will be tree node. So then, because we have the complement of this one is nodes, not empty, and for the last tuple in the nodes, so the depth matches the depth here in the function argument. So what we do is nodes pop. Notice that this list actually changed. So the level corresponds to the 1, right? The value, the level corresponding to 0 and the value corresponds to 1. So this is the root. So now let's set the root left. The root left will be make tree. So current state of the nodes, and then depth will be incremented by 1. So we first build the left subtree, and then we build the right subtree. The order here is important, right? So it's also depth plus 1. So notice that when we build the right tree, in other words, this line marked highlighted here, so this line already altered the nodes list, right? So that's important to notice. So now we just need to return the root. So that's the hyperfunction. Essentially, it's a preorder traversal. So now we just need to return make tree start from depth 0. So that's the sim. So now let's run and test it. Yeah, it passes the 3 test cases. Let me have commented out this one. Now let's submit. Yeah, it passes the generic cases. So that's basically about it for the coding. So here, let me give a quick summary. So here the point is to get the information about the node value and their level or depth. So here we have used a regular expression. If you're not very familiar with regular expression, you can look at the this module in Python. So basically, it will easily to get what's the meaning of this pattern. So once we get this, so then what it remains to write a recursion function to build the tree. So here we essentially do preorder traversal. So that's the first comment. Another comment, I guess, also important is that so the argument pass in Python. So in Python, the argument is passed by a reference. So you need to distinguish if a variable is or an object is mutable or not mutable. For example, here nodes is mutable, right? So that's why actually we don't need to do non-local, right? Non-local nodes here. If you use that, this is still fine, but redundant. Right. So it just because the reason is that this is mutable. So let me submit again. So that's the second comments. So with that said, I guess that's basically about it for the current video. If you find this video useful, you're welcome to subscribe on our channel with other playlists or videos. And you're also welcome to support this channel by forwarding it to your friends, your classmates, or anyone who might be interested in. Thank you.